Hello and welcome to session 11, where we're looking at ratios and proportions. In this session, you can see here you've got your session plan, the PowerPoint that I'm going to be using today, your activity worksheets, your knowledge check. So let's get into this. So we're going to understand and calculate using ratio, direct proportions, and inverse proportions. The aims and outcomes by the end of the session, learners must be able to simplify and use equivalent ratio and proportion diversions. Learners should be able to understand and apply direct proportions. Learners should, or learners could, sorry, also aim to understand the use of inverse proportions. Learners will be assessed on their ability to understand how to simplify ratios and the use of proportional figures. So just looking at ratios, here's how we can explain, or here is an explanation of how we use ratios. So you can see here we've got the amount of orange juice that needs to be diluted to water. It's 3 centimeters squares amount of water. So we're saying it's 3 centimeter squares worth of water to 6. Or 2 to 12, or 20 to 120. And you can see there, all that's happened there in the times table is it's just doubled up, hasn't it, from 6 to 12. And then obviously, if you think of 20 to 120 there. So the ratio is 1 to 6. This means for every unit of orange juice, 6 units of water is needed. Other quantities are shown in this table. How much water then is needed to mix 8 3 centimeter squares of orange juice? So if we think about it, you'll have 6 centimeter squares of water, times that by the amount of orange juice. So that's 8 centimeter squares. So 6 times 8 is 48 centimeter square. So equivalent ratios, the ratio of 1 to 6 is in our first example and can also be seen as 2 to 12 or 10 to 60, etc. Note that the 2 to 12 is the same as 1 to 6, and 1 to 6 has just been multiplied by 2, and that's what we said earlier. These are called equivalent ratios as they are rarely the same. Task. So you need your pen and paper here. You need to write down more equivalent ratios for 1 to 6. An example to write this down could be 15 to 25 in a similar way. So the solution here, we can divide both 15 and 25 by 5, and this gives us 3 to 5. We often write ratios in the form of 1 and n, where n is a positive number. So, for example, the ratio 3 to 5 in the form of 1 to n. Solution, to write the formula 1 to n, we can divide both sides by the ratio 3, giving 3 divided by 3, and then 5 divided by 5 gives us 1 5/3. So ratio for map scales, a map scale is given 1 to 20,000. What actual distance does a map length of 8 centimeters represent then in reality? So we need to know then that 1 centimeter on the map represents a real distance of 20,000 centimeters. So 8 centimeters on the map will represent the distance of 8 times 20,000 centimeters. That equals 160,000 centimeters. So 160,000 centimeters is as 1 meter as 100 centimeters, and 1.6 kilometers as 1,000 meters. So what is the map's distance in centimeters for an actual distance of 2 kilometers? So this is a reverse problem. We do 2 kilometers equals 2,000 meters equals 200,000 centimeters. An equal ratio of 1 to 20,000 is 10 to 200,000. This means the actual distance of 200,000 centimeters is represented by 10 centimeters on the map. So direct proportions. We can use direct proportions in this way. If 10 calculators cost £120, then one calculator costs £120 divided by 10 equals 12. So 4 calculators divided by 12 is 38, etc. These identical coaches carry a total of 162 passengers. How many passengers can be carried by 7 coaches? So again, there, 7 coaches can only carry, so if 3 coaches can carry 162 passengers, then one coach can carry 162 divided by 3, that equals 54 passengers. So 7 coaches can carry 7 times 54 equals 378 passengers. So hopefully you can see where that comes from. Yeah, good. Proportional division. So if we want to share £5 between 2 people in the ratio of 2 to 3, then one person will get 2 and one person will get £3. Suppose we now want to share £70 between 2 people if the ratio is 2 to 3. £70 divided by 5 gives us 70. Oh no, hang on, sorry. Go back. So that what we're looking for then is this is 2 plus 3 equals 5, because that's the 2 to 3. And divide by 70 equals 14. So 14 is 1 part, so one person gets, 2 gets 2 lots of 14, that's 28, and the third gets 3 lots of 14, that's 42. Check this total, 28 plus 42 equals 70, and this is correct. So, Julie and Louise makes a profit of £90 at a shared stall at the car boot sale. They agree to share the ratio 4 to 5. How much would each person get? So if we think about this and we break this down, so we have to do 4 plus 5, that equals 9. Divide 9 into 90, so that's then £10. So Julie gets 4 times 10, so that's 40, and Louise gets 4 times 10, that's 50. So that's a bit easier, isn't it? Good. So if we check that out, 40 plus 50 equals 90. Inverse proportions. This is when an increase in one quantity increases and decreases in another quantity. So, for example, riding a bicycle at 10 miles per hour, how long would that take for you to travel 20 miles? This will be 2 hours as you have to cover 10 miles and in 1 hour. Now, suppose you ride at the speed of 20 miles an hour. How long does this take? So 1 hour. In a car traveling at 40 miles per hour, how long will this take? Then half an hour. So you can see there, you will see clearly as this as the speed increases, the time taken decreases. So speed up and time taken are in reverse. So, and you can see the table there, 10 miles an hour is 2 hours, 20 miles an hour is 1 hour, 40 miles an hour is half an hour. So if you did yourself a little table, you could work that out quite easily, couldn't you? Can you think of other quantities that are in reverse proportions? So, looking now at cake production, in a bakery, each cake maker makes 50 cakes in 1 hour. How long will it take 2 bakers to make 50 cakes? And then B, 3 bakers to make 300 cakes. So it will take half an hour for 30 minutes for 2 bakers as the first time and number of bakers are in reverse. Okay, can you see where that comes from? So if one baker takes an hour for 50, then you halve that to half an hour or 30 minutes, and then 2 bakers will make the same amount of cakes. So it's just half. It will take 3 bakers just a third of an hour or 20 minutes to bake 50 cakes. So as 300 divided by 50 equals 6. It will take 6 times 20 minutes equals 120 minutes. So that's 2 hours to bake those cakes. So the aims and outcomes then. By the end of this session, learners must be able to simplify and use equivalent ratios and proportional divisions. Learners should be able to understand and apply direct proportions. Learners could also aim to understand and use inverse proportions, and learners will be assessed on their ability to understand how to simplify ratios and use proportional divisions in context. Please don't forget that you need to practice your activity sheets and track your progress and use your knowledge checker. You've now completed ratio and proportions. Well done.